Alright guys, if you are online, do well to signify. If you are online, do well to signify. If you are online, do well to signify. And make sure you share the video. Make sure you share the video. Make sure you share the video, guys. Ensure you share the video. Alright, so good evening to you all. I believe you all are doing fine. Before we start, ensure you share the video. Ensure you share the video, guys. Ensure you share the video. So in the course of this section, I'll be teaching us a very vital aspect in chemistry. All right, what topic should I even teach? That's what I'm thinking right now. Something I know that, okay, you just have to learn. So let's see how it goes right away. So ensure you share the live, guys, if you are here, and comment down where you are watching from. Comment down where you are watching from, and also ensure you see me soon. You are going to see me very soon. All right, you are going to see me very soon, guys. So just comment down where you are watching from. Comment down. All right, very good, very good. Others respond. So let's start right away, guys. Let's start right away. Let's start right away. All right, guys. Good evening to you all. I believe you all are doing fine. So in the course of this section, I'll be teaching on a very vital aspect in chemistry called radioactivity. Radioactivity. So that's what I'll be teaching in the course of this class lesson, radioactivity. If you are just joining this channel, or if you are seeing me for the first time, ensure you give this video a like and also share with your friends. All right. So radioactivity. So the first question you ask yourself is, what is radioactivity? That's the first question you are going to ask yourself, and it is very, very easy. Very good, very good. From Zimbabwe, from Abuja, from Lagos. Very good. So guys, ensure you engage, ensure you share the video with your friends. All right. So let's see how it goes. So in the course of this class, I'll be teaching you guys on a very vital aspect in chemistry called radioactivity. And what is this radioactivity we are talking about? Let's start. Radioactivity is on a very vital aspect in chemistry, and that aspect is simply called nuclear chemistry. What did I say? That aspect is simply called nuclear chemistry. You can see that nuclear chemistry is a part of chemistry. Chemistry is here, is very broad. We have different areas. We have nuclear chemistry, we have electrochemistry. That part of chemistry talks about electrolysis. We have organic chemistry, we have inorganic chemistry, we have physical chemistry. There's so much, but they are all very easy. I have so many videos on my channel that explains on all major aspects in chemistry. But in the course of this live section, let's just run through the topic radioactivity. So I just said that radioactivity is part of is a part under nuclear chemistry. From the word nuclear, I can actually tell you that this word nuclear came from a very vital aspect in chemistry called the nucleus. What did I say? The reason why it's called nuclear chemistry is because nuclear chemistry talks more on the nucleus of an atom. Alright, listen and listen very well. Just hold on. Let's define radioactivity first. What is radioactivity? Radioactivity is simply the spontaneous. Radioactivity is simply the spontaneous. I'm going to explain what spontaneous means. So radioactivity is simply the spontaneous emission of radiation. Alright, I'm going to explain. Radioactivity is simply the spontaneous emission of radiation from the nucleus from the nucleus of an atom. Wow. If you observe, listen, I said that radioactivity is simply the spontaneous emission of what? I'm going to explain what this means. I'm going to explain what each of the words means. So just listen. Emission of radiation from the nucleus of an atom. So you can see that in my definition for radioactivity, I still mentioned nucleus. That is why it's a proof to tell you that radioactivity is under nuclear chemistry. We are told nuclear is from nucleus. And you can also see nucleus relax. Now let me explain. The word spontaneous simply means something that can occur on its own. So radioactivity is the spontaneous emission of radiations, because there are more than one. So add S. You understand? So it's something like a spontaneous emission of radiation from the nucleus of an atom. So, you know, this atom we're talking about are elements in chemistry. Various elements in chemistry. You know, this nucleus, this atom we're talking about, it means elements. And you know here that the basic unit of an element, like the way the basic unit of life is called cell in biology, the way the basic unit of the kidney is called nephron in biology, is the way the basic unit of an element, is simply called an atom. Remember, on definition of an atom, you were told that atom is the smallest basic, the same thing, is the smallest particle of an element that can take part in a chemical reaction. So we have various elements in chemistry like hydrogen, helium, lithium, beryllium. So if you pick hydrogen, the smallest unit in hydrogen is what we call an atom. So all the elements have their smallest unit. So the smallest unit of any element at all is atom. Do you understand? So all this must be noted. So atom can be drawn with, I can use a diagram to signify an atom. So this an atom looks like in chemistry. An atom is made up of a structure that is centrally located. And this structure is simply called the nucleus of an atom. Because this is an atom, so I will call it the nucleus of an what? Of an atom. You know, in biology we also have nucleus. That's nucleus of a cell. Nucleus of an atom in chemistry was discovered by a man called Lord Ernest Rutherford. Lord Ernest Rutherford discovered the nucleus of an atom. But nucleus of a cell in biology was discovered by a man called Robert Brown. It's different. I did not say Robert Boyce. What am I even saying? I did not say Robert Hooke, because Robert Hooke discovered cell in biology. You understand? One of the earliest men to talk about cell. We have other scientists like likes of what? Felix Judadin. Yeah, there are so many. You understand? So in biology, in chemistry, the nucleus of an atom was discovered by who? Lord Ernest Rutherford. Note that. So now, this is the nucleus. You must also understand here that an atom is made up of 3 subatomic particles. Like inside, you know, I said that inside element, the smallest thing inside the element, they call it atom. So inside this atom, it has 3 smaller things. They call them subatomic particles. Subatomic particle means that they are found inside an atom. Subatomic, they are found inside an atom. I call them pen, which include proton, electron, and neutron. So these are the subatomic particles that are found in an atom. These are the subatomic particles that are found where? In an atom. These are the subatomic particles that are found in an atom. Alright, thank you so much, guys. Somebody said, my writing is fine. My writing is not fine. No. I don't know. Alright, let's progress. So as I was saying, guys, so what does that say? Radioactivity is the spontaneous emission of radiation. It's basically like from the nucleus of an atom. So for these radiations to be emitted, it must come from where? The nucleus of what? An atom. Do Do you guys understand? It must come from the nucleus, no other place. Now I have to tell us something very important. Where these subatomic particles are found exactly. This nucleus, that's where we see protons and neutrons, whereby electrons revolve around the nucleus. All these things that I'm using mark, I'm using like dash, this thing to signify, they are called electrons. Do you understand? But where is this radiation coming from? It's coming from where? The nucleus of an atom. It is not coming from where electrons are found. Is it coming from where electrons are found? No, from the nucleus of an atom. Are you guys following me? All these things are very easy, they are not difficult at all. So listen very well. They can ask you, where are this radiation coming from? You tell them that it is coming from where? The nucleus of an atom. Now, you can see that the way this element emitted radiation, it emitted radiation naturally. So that's why I said that it is spontaneous emission. Whenever you hear spontaneous emission, it has to do with that element emitting radiation naturally. We have elements in chemistry that emit radiation naturally. Those elements, they are naturally radioactive elements. But we have elements that they don't normally emit radiation, but we have to force them to emit radiation. You understand? We have to force them. So those elements, they are initially non-radioactive, but if we force them to emit radiation, they will be radioactive. Do you understand? This brings us to the two types of radioactivity, which is natural radioactivity, and the other type called artificial radioactivity. So this brings us to the type of radioactivity called natural radioactivity and artificial what? Radioactivity. For natural, the element is emitting radiation on its own. Artificial, you are the one going to, force that element to emit radiation. And I'll give us example. Listen. So initially, this element is non-radioactive, meaning that it does not emit radiation. But before we know this element becomes radioactive, what happened? Something will happen for any element to be non-radioactive to become radioactive. Something must happen for an element that is initially non-radioactive to be radioactive. So, me explaining that something must happen for an element that was initially non-radioactive to be radioactive, me explaining it to you, I'm explaining what we call artificial radioactivity. Artificial is like man-made, this man that is causing it to happen. Do you understand? And something that happens is what we call bombardment. What did I say? Bombardment. You bombard this guy that is non-radioactive to become radioactive, and you are bombarding the nucleus. You are bombarding the nucleus. When you are trying to shake the nucleus, then the nucleus starts emitting radiation. Then it tells us that that element that was non-radioactive becomes radioactive, and that explains artificial radioactivity. And artificial radioactivity sometimes can also be called transmutation. What did I say? Artificial radioactivity sometimes can also be called what? Transmutation. And this transmutation, which is also called artificial radioactivity, was brought by this same man. What did I say? This artificial radioactivity, also called transmutation, whereby an element that was non-radioactive becomes radioactive, was brought by Lord Ernest Rutherford. But the man that brought natural radioactivity, the one that occurs on its own, was a man called Henry Becquerel. Take note. Henry Becquerel. You understand? Henry Becquerel was the man that brought about natural radioactive. Becquerel. Do you understand? This guy that brought about the one that is natural. You understand? So all of these must be noted, guys. All of these must be noted. Guys, if you are just joining, ensure you give this video a like and share with your friends. So that is for that, guys. So we've seen the overview of radioactivity. So moving further, you can see here that I talked about that, okay, radioactivity is the spontaneous emission of radiations. So So the next point of this class is to stress on these radiations. Is to stress on what? These radiations. What are these radiations? That will be the question we ask ourselves. What are these radiations? Or wipe the board now. I believe you are following me. I believe you've subscribed and also share with your friends. So let's progress to talk about the radiations. Because these radiations are grouped into two majorly, and I will explain them. So guys, listen very well. Let's progress. I want to talk about these radiations. All of these radiations. All of these what? Radiations. What are these radiations, guys? The radiations are divided into two. We have the major radiations, and also we have the minor radiations. We have the major and the minor radiations. So the question you ask yourself, what are the major radiations and what are the minor radiations? What are the major and the minor radiations, guys? The major radiations, they are grouped into three. The major radiations, they are grouped into what? Three. They include the alpha radiation. If you don't call them alpha radiation, you simply call them alpha ray. They include the beta radiations. If you don't call them that, beta radiation, you can simply call them beta ray. And lastly, they include the gamma radiations. And if you don't call them gamma radiations, you call them gamma ray. So these are the three major radiations, and I will explain them one after the other. So take note. These are the three. Guys, ensure you like. Don't just watch without liking. Ensure you like the life. Don't just watch without liking. So now moving over, let's go over to the minor radiation. We've talked about the what? We've talked about the what do you call it now? The major radiation. Let's go back to the minor radiations. What are the minor radiations? They include number one, positron. There's something called positron. I will explain. Just listen. Another negatron. Another neutron, which we're already familiar with. We saw it in the initial explanation. And lastly, proton. So all of these are the minor radiation. Make sure they are extremely very, very important. So now, one is to know all of these radiations. Another is to know their symbols. Very vital. Another is to what? Know their symbols. What are the symbols of this radiation? Alpha radiation. The symbol is this. The symbol for alpha radiation is alpha. Is helium atom. Actually, is helium. He. And up is 4. Down is 2. Please, I beg you, note the symbol is very vital. Beta radiation is like this. Beta is like this. Here is 0 and here is -1. I beg you, note the symbol. Gamma is like this. It's like this. Up is 0 and down is 0. Note their symbols. We are going to use them very soon. What about these guys? Positron, negatron. I know that the name is ending with tron. It's sounding like proton. Is it sounding like proton? All these things sounding like proton. Listen, do you think it sounding like proton? Alright. Or sounding like neutron? Alright. Or sounding like electron? My advice for you to take note of this positron and negatron, they are like offshoot of electron. They are like offshoot. Listen. Negatron, they are like brothers and sisters. They are offshoot of electrons. So both of them are electrons. They will be symbolized as EE. But now the numbers that are attached to them differs, makes them different. You understand? Positron, this is it. Positron now it is 0 and +1. Negatron is 0 and -1. Are you not seeing difference? Please, I beg you, note the symbol. It will help us very soon. it will make sense very soon when we start applying all of these things to solve questions. Note the symbol as I've told you already. So you can see positron is electron 0 and plus 1, negative electron again 0 and minus 1. So neutron is symbolized as N, but it is 1 and 0. Whereby proton is symbolized as P, here is 1 and 1. I believe all making sense to you. All of these are the symbols of radiations in chemistry. So we've known their symbols. If you observe, negatron looks like beta ray because it's only the symbol that differentiates. The numbers are the same. The numbers are what? The same. Now, let me tell you guys something. You can actually know the charges of these radiations from major to minor. You can know the charges. The charge means that charge can either mean positive or negative. They can ask you, what's the charge for alpha radiation? How will you know the charge? Is alpha positive or negative? How will you know the charge? To know the charge, you look at the number down. You look at the numbers down. You look at the numbers down. So let's walk towards alpha to check if it's positive charge or negatively charged. I not see that number down is 2. And that 2 is a negative 2 or a positive 2. It's a positive 2. So then alpha is a positive radiation. Alpha radiation is positively charged. Whereby for beta radiation, I not see that it's minus 1. So it is negatively charged. Beta is negatively charged. Gamma, I not see that it's 0. That's why you were told that gamma is neutral. Gamma is neutral and can only be stopped by lead block. That's what can stop gamma radiation. Tin paper can be used to stop alpha and the rest. Don't worry, we'll get there. We'll get there. But you should understand that alpha is, you should understand that gamma is neutral because 0 signifies neutrality. It's not positive or negative, it's just neutral. Positron is positively charged, they just told us already. Negatron is what? Negatively charged. Neutron is also neutral. Wow. So out of all of them, how many are neutral? 2. Gamma and neutron. Proton is 1. So 1 means plus. Like 1 is like telling me that it's plus 1. So proton is positively charged. So to get your charge, you look at the numbers down. I believe all these things make sense. So after we've known all of these things, let's start solving some practice questions that pertains to this aspect of chemistry. So you listen very well. Listen carefully. Guys, ensure you like and also share with your friends. So let's progress. I'm about wiping because we are going to solve questions based on all of these things. I believe you've noted all of these radiations and their symbols. I'm about wiping now. Because we'll soon start solving questions. We'll soon start solving what? Questions. Questions. We've explained the introductory aspects to this topic. So it's very, very easy. So let's start solving some practice questions that pertain to this aspect. And what we'll be moving towards is how to balance radioactive reactions, how to balance nuclear reactions. Nuclear or radioactive, they're like the same. You can see it. Radioactivity came from nuclear chemistry. So what we want to learn now is how to balance nuclear reactions. They are all very easy. I'll give you an example, guys. I'm going to give us an example so you see how it's done. So you see how it's done. So for instance, you are given a question in your exam and here is U, here is 235, here is 92. They gave you an arrow. They wrote another element like TH. Here is 2, 3, let's say 2, 3, 1, and here is 90. Plus, here is a question mark. Everybody listen, oh, they are all very easy. Oh, they are all very easy. Everybody watch. This is how the question comes. This thing now is a nuclear reaction. It's different from your regular chemical reactions. Those your regular chemical reaction is where, for instance, acid will react with base to give you salt and water. And when this happens, you know that this reaction has a name. It's called neutralization reaction. These ones are normal regular chemical reactions. These guys are nuclear. Nuclear reactions are different from chemical reactions. We'll get there, you know, in subsequent classes. So you understand here that when I say something like this is a nuclear reaction, they're actually to balance it and it's very easy. To balance nuclear reaction is very easy. You focus on your up and focus on your down. You focus on your up and focus on your down. Now, this is one side, this is the left side of the reaction, whereas this is the right side of the reaction. What you are trying to do here is to ensure that the numbers you're having at the right and left are equal, both at the up and down parts. This is what I mean. Here is 2, 3, 5. Here is 2, 3, 1. Is these two things balanced? No. For me to balance it, we have to, is it right for us to add a number here or add a number here? Because if we add a number here, yeah, 2, 3, 5 will increase more, making this guy to not be balanced. So the best thing for us to do is to add a number here, up here, because we have to add up, number up, and another number down. Do you understand? So here is 2, 3, 1. So what do we add here to balance it 2, 3, 5? So here is 2, 3, 1, and I think if I add 4, it will give me 2, 3, 5. Hope you understand now. So I've added 4 already. Do you understand? So I think up is balanced because 2, 3, 1 plus 4 is 2, 3, 5. So here is 2, 3, 5. Let's check down. Here is 92. Here is 90. But I believe if I put 2 here, because 90 is plus, you are plusing, you are adding. So plus 90 plus 2, what's that already? 92. Wow. And me having something like this is any similar to one of the radiations I gave to us. Is there any similar to one radiation that looks like this? Is there any similar to one of the radiation that looks like this? He42. Hope you know now. And the radiation that is He42 is what? The radiation that is He42 is what, guys? What's that radiation? I told you guys already. It is alpha radiation. What is that radiation? It is what? Alpha radiation. So you can see that all these things are very easy. They are not difficult at all. They are not difficult at all. You can see that the answer, we've gotten it already. So in the question, they'll write different options. Let's say for instance, they write different things. So this is the answer. You see this one in one of the options and you pick this. So that's how you balance what? Chemical reaction. I'll give you guys more examples to practice with. Do you understand? I'll give you guys more examples to what? Practice with. I'm going to give us more examples to what? Practice with. So that is for that. So guys, before I progress, I believe you all can see the chemistry masterpiece, which is calculations and keynotes in chemistry. If you are preparing to write any chemistry related exam, be it you are in Nigeria or you are in any other African country or any part of the world, you can get the chemistry masterpiece. In this book explains strictly chemistry calculations. All what I've been teaching are inside the chemistry masterpiece written by me. So if you know you want to excel and improve greatly in your chemistry exams, then this book is actually a very important one you need to have. You understand? So for more information getting the chemistry masterpiece, you can direct message me via my WhatsApp number, and I'm going to write it here on the screen so you can direct message me. And here is it. Here's the WhatsApp number. 0. So this is the WhatsApp number. For others who are not here, who are not in Nigeria, this you can just remove the 0 and you can say +2 3 what 4. Continue, and basically you'll be able to reach me. You understand what I'm saying? So this chemistry masterpiece is very vital. All this I'm teaching, radioactivity calculations are all inside, and more other topics are inside. So for more information, do it to direct message me via my WhatsApp so you can get a copy for yourself. So guys, that is for that. So let's solve more practice question. Let's solve more practice question. Let's solve more practice questions that pertains to balancing nuclear reactions. There are others, there are other areas on radioactivity. There are others, but we are focusing in the course of this class how to balance nuclear reactions. So let's solve more other practice examples, guys. Let's solve more other practice example. Let's say, for instance, here is PB. Now you don't need to know the element, but I have to tell you this element is uranium, this element is thorium, this is uranium, this thorium. But you don't need to know the element. Even if you don't know the element, most important for you to know how it's solved. So this PB, this is 214, and this is 82 to give me Bi, bismuth. This is lead. PB is lead. Bi is an element called bismuth. It's not popular, but it's called bismuth. Here is 214, and here is 83, and here is question mark. So they ask you to get the question mark. Very easy. Watch. Here is 214, here is 214. So it shows that it's balanced. So what the number to add is just 0, because when I add 214 plus 0, it means that it is nothing. You understand? So up is balanced. Every part of up is balanced. I cannot add a number that is greater than 0, because if I do that, it will alter here. Let's say I add 1 here will be 215 and here will be 214 and it's not good. You cannot add a number here and add a number here. There's no space to add a number here. Just listen. All these things are easy. I'll give you a practice question. Here is 82, here is 83. So guys, for me to be able to balance here to be 82, what do you think I should do? I'll put -1. Hope you know now. The guy that do that, I'll say 83 minus 1, that's 82. Do you understand? So now you can see that I've gotten the number. But it's looking like one radiation I taught you guys. It's looking like this guy. Beta radiation. Or if I don't write beta, I can just say E0 minus 1, which is a negatron. You know, I told you guys that beta and negatron are literally the same. It's just the symbol that differentiates them. Hope you guys are following me. It's just the symbol that what differentiates them. So all that matters here, even if you don't know the radiation, you can try to just put 0 and -1 and put any number Z, any alphabet at all. It must not be necessarily the correct symbol. All that matters is that you know how to solve it. Do you guys understand what's happening? So let me give you guys another practice question to solve. So let me see how far you've understood all of this concept. They are all very, very easy. They are all very, very easy. They are all very, very easy. So I want to wipe the board now, guys. I want to wipe the board for another practice question. For those who are just joining, ensure you give this video a like and share with your friends. So here's another question. Lithium. Here is 6. Here is 3. Here is question mark. Here is HE31 and here is HE42. So what do we do, guys, to balance? Simple like ABCD. Simple like ABCD. Now, here is 6. Here is 7. 4 plus 3 is 7. So to balance it, I'll add 1. Hope you know that because 6 plus 1 is 7. Bam. Here is 7. Here is 7. Up is balanced. Let's check that. Here is 3. Here is 2. Sorry, here is 1 and 2. That's 3. So what do I do here? I put 0. So 3 plus 0 is 3. 1 plus 2 is 3, here is 3, down is 3. So what looks like 1, 0, I think I told you already, Ni, neutron now is neutron. But as earlier said, you guys can just decide to write anything. You can decide to just write Z. You can decide to write Q, anything. But all that matters, that's why I told you guys, be familiar with those symbols so that you write it correctly. But all that matters is that you know what is happening. You know how to balance it. So that's the answer to this word question. That's the answer to what? The question. They are all very easy. They are all very easy, guys. So if where you're watching, just comment down where you're watching from, so I'll know where you guys are watching from. Comment down where you're watching me from right now. So let me find another question and solve for us. Let me find another question and give to us, and let me show you how it's done. All these things are very, very easy. Let me wipe. This is another practice question we're about solving now. Another one. So when you encounter a question like this, D, here is 2, here is 1, here is big 2 standing in front, here is H, here is 1, here is 1, and here is T, here is R and S, meaning they're asking us to get R and S. So first of all, when you see a number standing in front of an element, a big number standing, if you observe, we did not see something like this initially. My advice is to times. Times. Do you understand? Times. When you times, you use this big number to times the up and down value. Only this guy, you know everything. Only this guy. So when you do that, it will be 2 times 2, 4. 2 times 1, 2. Do you understand? 2 times 2, 4. 2 times 1, 2. Do you understand? So let's rewrite. To give me what? H11 plus what? T ROS. So you are looking for ROS. So here is 4, guys. Here is 1 already. So what do we add here? 3. Because 3 plus 1, that's 4. 3 plus 1, that's 4. 3 plus 1, that's 4. Here is 2. So what do I do here? 1. 1 plus 1, that's 2. 1 plus 1, that's 2. 1 plus 1, that's 2. Do you guys understand? They are all very easy. No matter how the question comes, insofar as on this aspect, you've known it already. But there are still more other things to learn on radioactivity as far as radioactivity is concerned, and they are all in the chemistry masterpiece written by me, calculations and keynotes in chemistry. For more information, getting the chemistry masterpiece, do have to direct message me via my WhatsApp number. It's already on the screen or on the board, so you get a copy for yourself, irrespective of where you are from. All right. So, guys, that is for that. So, with all this said, very good. With all this said, we've come to the end of this live section. So for more learning, for more topics to learn in chemistry, I've done them on my channel, ranging from introductory chemistry down to organics. Have so many videos on my channel to help you improve greatly. So you should ensure you go watch the videos on my channel to learn better. All right, to learn and learn and learn. So guys, we've come to the end. I see you guys when I see you guys. God bless you all. Ensure you share my videos with your friends. Ensure you engage anytime I post a new content. Let's get to 100,000 guys. It's very possible, right? 100,000 subscribers. Let's get to 100,000. It's very possible. It's very possible. Currently I'm at 70 something thousand. So what's 100,000 that we cannot get? So let's get it, guys. Ensure you share these videos. Ensure you share my videos. Engage to learn more in chemistry and as well as in biology. God bless you all. I see you guys when I see you guys.